One of the overarching themes about using Windows Azure Storage is the concept of tightly integrated and loosely coupled. We want systems that work closely together but that aren't bound together, meaning we can use one or all, but we don't need to use all of them at the same time. They're not required. The tightly coupling leads to brittleness, but if we can use the tightly integrated, loosely coupled approach, this can aid in scaling and performance. So what is a queue? Queues are used to store messages, and they're a first-in, first-out method, and one way only. A queue name must be lowercase name and must be URL friendly. So think of this in the example of a ticket booth. Customers come in one end, and it's first come, first served, so first in, first out. The line only moves one direction. Queues hold messages. A queue can hold an unlimited number of messages, but the message must be serializable as XML. And for now, the limit to the size of a message is 8 kilobytes in size. And a common use for messages is the work ticket pattern, as you're processing tickets or messages as they come in. Now, Windows Azure Storage Queues has the concept of a queue garbage collector. This queue garbage collector runs once a week, deletes all messages that have not been processed in the last 7 days. So let's talk about queue terminology. You have producers of messages, you have consumer of messages, and then you have the queue. You have the top of the queue and the bottom of the queue. Producers will put messages on the queue, and those messages go on the bottom of the queue. And you have consumers, and you can have multiple consumers as well, and they are pulling messages from the top of the queue. And it's a first-come, first-served basis, and we'll talk about that shortly. Let's talk about the life cycle of a message. Here we have a web role. It's accepting requests from an application. And here we have a queue. And this web role is receiving requests to put messages on the queue. In this example, the web role has just put message 1 on the queue. And it goes back to the application and says, yep, I just put message 1 on the queue. And as well, it can put multiple messages on the queue. So it put message 2, 3, and 4 on the queue. On the other side, we have worker roles. On the left, we have one web role whose job is to put messages on the queue. But on the right side, we have multiple worker roles, worker role 1 and worker role 2. In this example, worker role 1 grabs the first message. And to do this, it calls the getMessage method on the queue client. And you can optionally specify a timeout method. The default is 30 seconds. So it grabs message 1. And when it's all done processing that message, it calls the removeMessage method. Worker role 2 then grabs message 2. And while it's processing it, the timeout expires, which then puts message 2 back on the queue. But as far as worker role 2 is concerned, it's still processing that message. Because message 2 is back on the queue, worker role 1 can then grab that message. But then when worker role 2 is done with processing that message, it then goes back and tries to delete that message, but can't because worker role 1 has grabbed that message. Let's talk about working with queues. The key to working with queues is to create a cloud queue client. But before you can start working with queues, you must get a reference to the cloud storage account. And once you have an access to the cloud storage account, you can create an instance of your cloud queue client. And once you have an instance to your cloud queue client, you can then get a list of your queues and start enumerating through your list of queues. As you're enumerating over your queues, you can then initiate an instance of a specific queue by specifying the name, or you can create the queue if it does not exist by calling the createIfNotExist method for that queue. Once you have a reference to a specific queue, you can clear the queue, which deletes all its messages. You can delete the queue, or you can actually set the queue to null, which means you're actually working with no queue at all. So once we have an instance of a queue, we can then start working with messages. So the goal there is to then create an instance of your cloud queue message. So you create a new message, then you call the add message on the queue to add the message to the queue, and then you call the bind message list to add that to the queue. So Windows Azure actually gives you the ability to peek at a message. Peeking lets you see the contents without actually getting the message. It's handy when you're trying to determine how to handle a message without actually consuming the message. so you can peek at the message, determine if this message is for you, and either get the message or ignore the message once you've peeked at it. And it's very simple to do. Once you have an instance of your Cloud Queue message, you can actually do a peek message. The great thing about this, too, is that you don't have to do this one at a time. In the second example here, it's actually showing you how to peek at 10 messages at once and not just one at a time. Let's talk about the concept of getting a message. When you get a message, you can specify how long you want to hold that message. By default, the visibility is 30 seconds, but it can be as long as 2 hours. Here are some examples of how to get a message. The first line simply gets a single message. Once it has a reference to a queue, you can then call get message to get a single message. Because a time has not been specified, the default will be 30 seconds to hold that message. The second example gets a message but specifies a time of 45 minutes. So this queue consumer will hold this message for 45 seconds prior to either deleting it or putting it back on the queue. The third line actually gets more than one message. It actually gets 10 messages. So you don't have to pull a single message. You can get multiple messages at a single time and process multiple messages. So the third line actually illustrates how to get multiple or pull multiple messages off the queue. And in this example, it's pulling 10 messages off the queue. Deleting a message is very simple. The message ID and the POP receipt must match for a successful delete. And it's as simple as calling the delete message method, passing it the message that you're processing. Now, one of the key concepts of working with queues is pulling. How do you pull messages off the queue? Now, most queues are pulled in an infinite loop. So the key to pulling is to not affect the polling process as you add more message consumers. So here's an example of how you could implement polling and the pulling of messages. Typically, you'd want to implement this in a while loop. So in this case, we have a while loop, and the Cloud Queue message pulls the first queue off the message, and if there's actually a message there, it will process that message, and then when it's done processing that message, it will actually delete the message. Otherwise, sleep for a second and then loop. However, that continually pulling mechanism could have an effect on performance. For example, why waste resources in the evening if there's no messages to pull? So one of the things you can do is to implement an exponential back-off polling mechanism. For example, what you could do is you could say if there's no message to process, increase the interval of polling by 2. And then as soon as I find a message, I can set the interval back to a value of 1. Here's an example of how you might implement exponential back-off polling. In this example, it says if I find something, gradually decrease my polling interval. Otherwise, if I find nothing to process, increase my polling interval by 2, and then sleep for that period of time. Let's walk through an example of how we might implement queuing with shopping. You can think of this in terms of Amazon. When you order something off Amazon, you usually get 2 or 3 emails letting you know that your order's been received, your order's been processed, and your order has been shipped. This is the same thing. So when my request comes in, it goes to the server. A message is sent back to the server saying I've been processed, and then it goes to the next step and says, okay, I've now been processed. Now send another message back to the originating source. There is the concept of a long queue, and a long queue is a queue that collects messages for a period of time while the consumer is offline. Then the consumer might come online once a day to process all the messages, then sleep again. This is useful for processing messages from an external vendor, for example. There's also the concept of state-directed queues. It's a nice way to break up complex processes into states. Each state is a separate process, pulling a dedicated queue. So let's take a look at that. Here I have a simple producer that's producing a website. That message then goes into a big worker role, the verify, ship, and notify process, and then gets notified into completed. This is an example of a state-directed queue. However, we can do the same thing with multiple queues. Instead of having a single queue, we can break this up and have multiple queues. So our message goes from one queue to the other as the state of that message changes. So we're going from new to validated to ship to shipped to notify, and then once it's notified, it's completed. This is another example of taking a state-directed queue and using multiple queues instead of one queue to process a single message. So with that information, let's do a demo about how to work with queues. In this demo, I'll show you how to build a simple Windows Azure queue solution that creates a queue, places messages on that queue, and then reads those messages from the queue. But before we do that, we need to provision our Windows Azure storage account. So let's go into our Windows Azure portal, and we need to select the Hosted Services Storage Solution in CDN node. And then from there, we get a list of options we can select, and we need to select the Storage Account option. So notice that we have no accounts provisioned for our AppDev Cloud solution. So we need to provision that account by clicking the New Storage Account button. So it's already got our subscription selected, but we do need to provide a URL because remember, we can access our Windows Azure storage via the REST protocol, so we need to give it a name. So for this example, we'll give it AppDev Queue. Good enough. Let's choose our region. We'll select the North Central US, and that's all we need to do to create our storage account. So let's click Create. So there's our account. It's been created. Now remember in our discussion of queues that whenever we need to access our storage account, we need to provide the storage account name and the key. And so over here to the right, we have our primary access key and our secondary access key. And there's our blob URL, or there's our URLs if we want to get to the blobs and tables and queues. We won't use these for this demo, but we will need the primary access key. So let's go ahead and grab our primary access key. It's going to generate that on the fly. And there's the beginning of it. We're going to copy that to the clipboard. Yes, we want to allow that to copy to the clipboard, and let's click OK. So it's much longer than that. It shows you the first few characters. We've copied that to the clipboard. Let's click OK. We're also going to need the name as well, so we just need to remember it's AppDev Queue. So now we're ready to start our demo. So let's fire up an instance of Visual Studio 2010. Now typically we would use this in a web role or a worker role, but for the sake of this example, we're going to create a Windows Forms project. And we can still use that to get to our queues in our Windows Azure storage in the cloud. So let's create a new project. We're not going to create a cloud project, we're going to create a Windows Forms application. And we're going to call this application Queue Demo. And click OK. Now again, we're not going after beauty here from a design perspective. All we need to do is just illustrate functionality. So on our form, we're going to go to the toolbox. And we're going to drop a button. And we're going to scroll down on our list box, and then we're going to drop a list box. So let's rearrange this a little bit. Let's change this a little bit. Let's open our property dialog, and we're going to change the text of this button to run, and we'll change the code to, or the name of this to command run. All right, now we're ready to go. We can start writing code. Now, remember, to access any of our Windows Azure storage, we need that account name and account key. So let's go to our code behind the form, and here's where we're going to do all our work. Let's go back to our design because we want to put code in our form load. So let's go ahead and double click anywhere on the form. And there's our form load. And let's go back to design and double click the run button because we will also want to place code in the click event of the button. First thing we need to do is we want to define our credentials. So right in here we're going to create a region where we can define our credentials. I'm going to say string account name equals. This is where we're going to put our account name, and then we're going to say string account key. This is where we'll put that account key that we copied to the clipboard, and then we'll just and region. Okay, so we know from our creating our storage account that our storage account name is appdevq, all lowercase. So we're going to put that in here, account appdevq, and we know that our key we pasted to the clipboard, so we should have it on the clipboard, and there it is. So we're going to place that there. All right, we're all done. Now we can start writing code to use this information and to start building the queue and reading and writing messages to and from that queue. So the first thing we're going to do is we're going to go down to our load event, and we're going to say the following. We're going to write the following code, because what we need to do is we need to create the queue if it doesn't exist, and there's methods to do that. But before we get started, I forgot a couple things. Because we're doing a Windows form project, the solution does not automatically include the appropriate references to access the API that we've talked about. So we need to go and add those references. So we need to go to our Solution Explorer, to our References node, and right-mouse click the References node and select Add Reference. We need to browse to these, and these are located in our Program Files directory. So we need to go to Program Files, and it's down in our Windows Azure SDK folder, version 1.4, and in our Reference folder. And we need to select a few of these files here. So we need Storage Client DLL, the Service Runtime DLL, and if we want to include any diagnostics, we'll include the Diagnostics DLL. Click OK. Now I'm going to save you a little bit of time here, because there's one property we need to change on this project that if you don't change, you'll get a lot of errors and you'll wonder why you're getting these errors. So let me save you a lot of time and show you where that issue is. So if you right-mouse click the project and go to Properties, the problem is that when you create a standard Windows Forms application, the target framework is the .NET Framework 4 Client Profile. This is not what we want. We need to change this to just the standard .NET Framework 4 profile. It's going to ask us, hey, we need to reload the project. Go ahead and click yes. It'll reload the project. If we don't do that, the project has a hard time referencing those files that we referenced, the Azure storage files that we referenced. And so you'll spend a lot of time figuring out why you're getting compilation errors. Just a good FYI. So now that we have the appropriate files referenced, we can start adding code. So let's right-mouse click the form, click on View Code. Now we can start adding code to our form load event and our click event of the button. But let's start with the form load event. So here we need to say, forgot one more step. We need to go back up here to the declaration section, and we need to add a few using statements to our form so that we can use those references that we just added to our project. So it is using Microsoft.Windows Azure down here, .storage client. We need to add the using Microsoft.Windows Azure .service runtime. And we're going to add one more. We're going to add the using system.threading. That threading allows us to sleep as we're looping, and you'll see that in a minute. And we're going to add, actually we're going to add one more. We're just going to add using Microsoft.Windows Azure. All right, now we can start adding code. So the first thing we need to do is we need to create an instance of our storage credentials account and key reference. We don't need to do this if we're running this in a web role or a worker role, but because we're doing this in a Windows Forms application, we need to do this. So we say storage credentials account and key. Call this credentials equals new storage account credential key, and we're going to pass the account name and the account key that we defined above. All right, now that we have that, we can actually create an instance of our cloud storage account that we need to get access to our queues, blobs, and tables. But for this example, access to our queues. So we say cloud storage account, equals new cloud storage account. We need to pass it the credentials that reference the credentials from above. And we're going to tell it to use HTTPS, so we're going to set this parameter to true. All right, now that we have an instance of our cloud storage account, we want to grab an instance of our Cloud Q client. So we're going to say Cloud Q client equals our cloud storage account dot create. Whoop, I typed that wrong. Dot create Cloud Q client. Just like that. Now we can get access to a specific Cloud Q. So we're going to say Cloud Q equals Cloud Q client dot get Q reference. And we're just going to call this test Q for now. And on our Cloud Q, there is a method called create if not exists. And there we go. So in the form load, we create an instance of our credentials. We define the credentials, our account and key. We create an instance of our cloud storage account. From there, we create our Cloud Q client. And from there, we can get an actual reference to the test queue. And then using the getQ reference method, we can actually get a reference to the test queue. And then from the Cloud Q class, we can call the create if not exist method to actually create the test queue if it does not already exist. So we've added our code to the form load. Let's scroll down and add code to our click event of our run button. In our run button, we're simply going to loop several times to place messages on the queue and then read those messages from the queue. So to make this sample a little simple, we're actually going to copy this code from our form load event, and we're going to paste that into our click event of our run button. Since we're iterating, I want to illustrate putting messages on the queue and reading those messages off the queue. So I'm going to define a counter that counts those messages. So I'm going to say int I equals 1, and then I'm going to paste the code from our form load event. Now typically you would not do this, but just for the simplicity of this example, I'm going to paste that here. Simply because since we're accessing the queue again, we again need to specify the credentials and get access to our cloud storage account and the specific queue that we want to work with. So we're going to say, now we're going to loop, and while we loop, we're going to place messages on the queue and then read those messages from the queue. So we're going to say while true. So we're going to start looping. And within the loop, we're going to actually create messages to place on the queue. So we're going to say cloud queue message and define that as CQM equals new cloud queue message. We're simply going to pass a string as the contents of the message. We're going to say this is a test message in plain text. Now, the reason I created that counter earlier is because I want to illustrate that the messages are actually going on the queue and that we're reading them from the queue. So I'm going to append this counter to every message. So to do that, I'm just going to say add the plus convert to string, because I want to convert that integer number to a string and append that. So there we go. So we've just created our cloud queue message. I'm going to add that message to the queue by adding the add message and passing it the cloud queue message that we just created. And so all we need to do to create the message and add that message to the queue. Now let's read that message off the queue and add the contents of that message to the list box that we placed on the form. So we say now read the message from the queue. So we'll define another cloud queue message. And this is our receive message equals cloud queue dot get message. We're not going to specify a message time here. The default is 30 seconds, and for this example, that's good enough for this sample. Now we'll add the contents of that. That's not the right one. It is .get message. That's what we want. So we're now going to add the contents of that message to the list box. So say list box 1.items.add, and we'll say, and we'll take the contents of that message that we received and say toString. Okay, and then let's refresh the form so it displays appropriately at the appropriate time, the contents of the list box. Then let's delete the message because we don't need it anymore. Delete message. And we need to pass it the message that we just pulled off the queue. Now, we need to know how many times we're going to loop. So here we're going to say we'll just loop for, let's say, 50 times. And then if we've got 50 times, stop looping, we're good to go. We need to increment the counter. If we're under 50, let's sleep for a second. We'll sleep for just a fraction of a second. All right, well, there's our example. So let's run that. Let's compile it first and see if there's any errors. Rebuild all successful, so we're ready to run this. So we run this. Let's go ahead and start debugging. So we didn't get an error, so we know that the queue is created. So go ahead and click Run. Oh, we have an error, so we need to stop this. It should be returning this is a test +1. So we need to figure out where our error is. Aha, I know where the problem is. This needs to be .asString, not toString. That should fix our problem. So this is a property, not a method. So we need to take off those parentheses. There we go. So let's save this. We're ready to go. So let's run this. Now, remember in the load event of the form, it'll still run that code, but it won't create it because the createIfNotExist method will see, hey, this queue is already created, so it won't need to create it. So now if we click Run, we should get the appropriate information. There we go. Now that's working. So this is a test message in plain text 1, 2, 3, 4. So the way this is working is it's looping and creating a message and appending the number 1, 2, 3, 4 to the end of the text. Placing that on the queue, simply reading that message off the queue, grabbing the text of that queue and writing it to the list box, and then deleting that message from the queue. So there you have it, a very simple illustration of how to work with queues to create a queue, place a message on that queue, and then read those messages from the queue.